Okay, now let's discuss the second partial exam. The first problem, find the distance and the midpoint between the pair of points. So first point is -6 and 2, and second point is -2 and 3. Question asks you to find the distance between them and the midpoint between them. Distance x1 minus x2 squared, y1 minus y2 squared, and sum of them take square root. Okay, so x1 -6 minus x2 -2 squared plus y1 2 y2 3 squared. Okay, -6 minus -2 is -6 plus 2 is -4 squared. 2 minus 3 is -1 squared. 4 squared, 6, and -4 squared, 16. -1 squared, 1. So it's a square root of 17. So the distance is a square root of 17. Midpoint. Midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. Alright, so x1 -6 plus x2 -2 over 2, y1 2, y2 3 over 2. So -6 plus -2, -8 over 2, -4. 2 plus 3, 5. 5 over 2 is 5 over 2. So this is the midpoint, -4, comma, 5 over 2. That's the first problem. And second problem, determine the center and the radius of the following circle. So the circle equation is given by x squared minus x plus y squared plus 3 over 2y, 3 over 2 times y minus 7 over 2 is equal to 0. Right? So first you move this constant term to the right side. Becomes 7 over 2. And then you complete square for the x terms and the y terms. So it's a x squared minus 2 times 1/2 times x. Always divide the coefficient by 2 and times 2. And then you see here, this is 1/2. So you plus 1/2 squared. Y squared plus 2 times 3 over 4 times y. And plus 3 over 4 squared. And is equal to 7 over 2 plus 1/2 squared plus 3 over 4 squared. That's the right hand side. Right? So this is a very standard complete square. Okay. And then you are going to combine the first two terms as x minus 1/2 squared. And the y terms is y plus 3 over 4 squared. Is equal to, you're going to add all these numbers together. It's a 69 over 16. You add all these numbers together. This is a 1 over 4. This is a 9 over 16. So you write everything in terms of a denominator 16. You will get this is a 56 over 16. Here is a 4 over 16. Here is a 9 over 16. Add them together, 56 plus 4 plus 9 is a 69 over 16. Right? After you get this 69 over 16, the center is 1/2, that's from here, comma, -3 over 4. It has to be negative. The radius is here, this part is radius squared. This is r squared. So r is square root of 69 over 4. You can take square root of 16, you get 4. So you can either you can just write this as square root of 69 over 4. Right? So that's a second problem. And third problem, you have 2 points, 1, 2, and negative 2, 1. Write an equation of a line through these 2 given points. Okay, write the equation of a line through these 2 given points. So you already have 2 points. You need the slope. Slope is y2 minus y1 over x2 minus x1. So it's a y2, negative 1 minus y1, 2. x2, negative 2 minus x1. So it's a negative 3 over negative 3 is equal to 1. So the slope is 1. You have slope, you can pick up either of them. So for example, y minus 2 times slope x minus 1. Or you just write y minus 2 is equal to x minus 1. Or you can write y is equal to x plus 1. Either way, you can write here this way. This will show you the slope and the point. This is a point slope form. Or you write this one. Right this way, this is a slope intercept form. Okay, so that's the line through the given 2 points. This is line equation. Okay, so that's the first 3 problems. Problem 4. Problem 4, you have a line 5x plus 9y is equal to 45, and you have a given point negative 2, 5. Write an equation of a line perpendicular to this given line and passes through the given point. Okay, 2 lines are perpendicular. 2 non-vertical lines are perpendicular if and only if the product of 2 slopes is negative 1. So first, let's compute the slope of first line. Copy the equation and move 5x to the right side and divide by 9. Divide the equation by 9. So from this slope-intercept form, we get the first slope is 5 over 9. And together with the first slope times second slope is equal to negative 1, you can compute the second slope is going to be negative 1 over first slope. It is 9 over 5. It is 9 over 5. So the line perpendicular to this given line should have slope of 9 over 5. It also passes through the given point. So by the point slope form, y minus y coordinate, slope times x minus x coordinate. Don't simplify it. Just leave it like this. Okay? It's like this. Point slope form. That's the fourth problem. Problem 5. We have equation negative y plus 4 is equal to x squared minus 4x and plus 8. Find all x, y intercepts. Find all x, y intercepts. So x-intercepts. We're looking for x-intercept. We will let y be 0. Y is 0, so left hand side is just 4. So you get 4 is equal to x squared minus 4x and plus 8. Move 4 to the right side, x squared minus 4x and plus 4. You cancel. It's 8 minus 4 is equal to 0. And this one is x minus 2 squared is equal to 0. Then you will get a repeated solution, x equal to 2. All right, so there's only one x-intercept, but it's actually repeated. 2 is the unique x-intercept. X-intercept. Y-intercept. Y-intercept, you will let x be 0. You let x be 0, so this term becomes 0, this term becomes 0. So it's a negative y plus 4 is equal to 0 minus 0 plus 8 is equal to 8. And you move 4 to the right side, it's negative 4, and negative y is equal to 4, so y is equal to negative 4. So negative 4 is the unique. You don't have to write unique, this word, but it is a unique y-intercept. So this equation has one x-intercept, has one y-intercept. Okay. Problem 6. We're talking about a parabola. Parabola has a focus 0, 1 over 3. Directrix y equal to negative 1 over 3. This is a standard form we discussed in the class. Here's A, here's a vertex, here's a directrix y equal to negative A, then the parabola like this. The equation is x squared is equal to 4ay. A is the y-coordinate of the focus. So from here, you see that A is 1 over 3. So the equation becomes x squared is equal to 4 times 1 over 3 times y. You just replace A by 1 over 3. It's a 4 over 3y. X squared is 4 over 3y. This is the equation. Okay. Problem 7. Problem 7, we are given a function f(x) is equal to the fourth root of negative 2x squared minus 3x and plus 2. We're looking for the domain of this equation. Fourth root, square root, sixth root, all the even root function require the input under the root function. It should be greater than or equal to 0. So we require negative 2x squared minus 3x and plus 2 greater than or equal to 0. Greater than or equal to 0. We multiply this inequality by negative 1 minus 2 less than or equal to 0 because we want to convert all the quadratic function with leading coefficient positive. Okay, and then this one, well, first we solve the equation. We can factor it as, remember, we multiply 2 with a negative 2, we will get a negative 4. And negative 4, we break it as a 4 times negative 1. 4 times negative 1 is negative 4. 4 plus negative 1 is the 3. So we will have 2x plus 4x minus x. So 4 becomes 4x, negative 1 becomes minus x, and minus 2 is equal to 0. The first two terms you factor out 2x, and last two terms you factor out the negative sign. So it's x plus 2 and 2x minus 1 is equal to 0. So from here you get x is negative 2 or x is 1/2. You have negative 2, 1/2. Negative 2, 1/2. Then the quadratic function, remember we always require this leading coefficient to be positive. So the quadratic the parabola always has opening upward. So it's like this. We need it to be less than or equal to 0. So it's between negative 2 and 1/2. So the domain is between negative 2 and 1/2. At negative 2 or at 1/2, the function, this input is 0, so it's allowed. So that's why we use bracket. All right, so that's our problem 7. Let's see, problem 8. Problem 8, let fx be 2x over x plus 2. We have this given function, 2x over x plus 2. Question 1, is the point 1/2 negative 2/3 on the graph or not? We want to determine if this point is on the graph of this function or not. So to make sure it is on the graph or not, we have to evaluate the function at 1/2. So we just evaluate the function at 1/2. So 2 times 1/2, 1/2 plus 2. 2 times 1/2 is 1. 1/2 plus 2 is 5 over 2. 1 over 5 over 2 is 2 over 5. And this value, of course, is not equal to negative 2 over 3. They're different. So the point, you have to answer it, write the sentence. The point 1/2 negative 2/3 is not on the graph of y equal to fx. This fx. Okay, it's not on the graph. Part B, if fx is equal to 3, what is x? We're looking for the solution of this equation. Okay, so because they require fx to be 3, so we just let 2x over x plus 2 equal to 3. We solve for x, multiply two sides by x plus 2, and keep simplification. 3 times x, 3 times 2, 6, and 2x on the left side, 3x on the right side, we cancel 2x, we get x. Move 6 to the left side is negative 6. Okay, so you move this to the left side, becomes negative 6. Here, move to the right side, 3x minus 2x is x. So x is negative 6. X is negative 6. So the answer, what is x? X is equal to negative 6. That's problem 8. Problem 9, find the average rate of change. So we are given a function 2x cubed minus 4x squared, and we're given the interval 1, 2. So we're looking for the average rate of change. This is A, this is B. Then it is FB minus FA over B minus A. Here A is 1, B is 2. A is equal to 1, B is equal to 2. So we need to know what is F1. F1 is a 2 minus 4. F1 is 2 minus 4 is negative 2. F2 is a 2 times 2 cubed is 8 minus 4 times 2 squared is a 4. 2 times 8, 16. 4 times 4, 16. 16 minus 16 is 0. So F2 is 0. So the average rate of change for this case becomes FB is F2 is a 0 minus FA, F1, negative 2. Right? You put it here, and this 0 is here. And 2 minus 1, B minus A. So 0 minus negative 2 is 0 plus 2 is 2. And 2 minus 1 is 1. 2 over 1 is 2. So the average rate of change is equal to 2. Okay, follow the right formula. Okay. Now problem 10. Problem 10 show that the function fx equal to x cubed minus 3x squared x to 5th power. This is an odd function. It's an odd function. Show this is correct. To show a function is odd, you're going to compute f negative x. F negative x is negative x cubed minus 3 over 2 negative x to the 5th power. we know that for all the other power, negative sign can be moved forward. So it's negative x cubed. You can move this negative sign outside of the parentheses. This is cubed. Fifth power, same thing. You can move it outside of parentheses. Then when this negative sign is moved outside, negative becomes positive. Okay, that's a simplification. This is the f negative x. And then you compute negative fx. Negative fx, you just put a negative sign in front of the whole expression. And then you distribute this negative sign into it. Right? You put it here, you put it here. And then you check here, this one is exactly this one. So it is equal to f negative x. Negative fx is equal to f negative x. So f is out. In the problem, you must clearly compute f negative x, negative fx, and write down they are equal to each other. So f is odd function. 11, last problem. So we're going to show the function fx, which is ops value of x over 3x to 6 power plus 1 is an even function. Is an even function. Similar, f negative x. f negative x is ops value negative x, 3 negative x to 6 power n plus 1. We know that for the ops value function, it will kill the internal negative sign. So ops value of negative x is ops value of x. Negative x to 6 power. 6 power, you have even negative sign. Even number of negative sign will be cancelled. So it's a 3x to 6 and plus 1. And this, you check that this one is exactly fx. So by this evaluation and the simplification, you see f negative x is equal to f of x. So f is an even function. You have to literally evaluate, simplify, and set up the equality. So you get an even function. All right, so we are done. So that's all the problems. Let's start from the beginning. This is the first page. First, the 3 problem. And problem 4, 5. Problem 6, 7. Problem 8, 9. And the problem 10, 11. All right, thank you.